Before we start class, I think I can introduce myself. All right. My Chinese name is Ping Zhengyang. Because I know the Mandarin, the Chinese is the most difficult language to learn all over the world, maybe. One of the difficult language. So maybe for you, it's very difficult to remember my Chinese name. So you can call me my English name. It's Gavin. All right. I'll send you my English name in the chat box. Yeah, Gavin. Okay. Gavin. And the training content is like that. Uh, Actually, we have 10 days. The duration of this course is 10 days, right? 10 half days. And the training content is including 11 slides. And the first, today's topic is the network basics. And the second is the security concepts of the cybersecurity concepts. And third is the network security threats and prevention, which consists of several methods to tell us how to prevent our network system from the hacker, right? And fourth one is the firewall, which is the core device in our cybersecurity system. And NAT technology, network address translation, and hot standby technology. And the seventh one is IPS, which is the operation device of the firewall. Actually, the function of IPS and firewall is different. And the user management technologies and fundamentals of encryption and decryption, and the PKI, and encryption technology applications. And these are all the contents of this training slide of this training project. All right, and so happy to see you. Okay, this is the agenda. And next part, I'll introduce you how to use the online platform to view the training materials. As you can see, there are so many training slides, right? 11, and including one, the lab guide. And I'll show you how to log in a website and view these materials, all right? I'll send you a link in chat box. Can you see that? Can you see that? I share you a link. I just shared you a link.
Yes.
Yes, please open that. Please open this link. I'll show you step by step. Okay, the first step is copy this link and open your browser and paste this link. Because I have already logged in, so I think I need to log out. Okay, switch the website page to the English version. And you can see this is English mode, right? Once you open this link, you can see the page as I do, right? And you can use your email. Maybe the Gmail or something else, to receive a verification code and log in. All right. I'll give you 5 minutes. 5 minutes to finish that registration. Email address and click this get verification code, and your email box will receive a message including one verification code, and input the verification code in this blank, and click this I have read and accepted service agreement and privacy policy. After that, log in and sign up. All right, 5 minutes. And if you have any questions about this step, please let me know. Send a message in the chat box. All right? Can you open this link? Hello, everyone.
Yes, I am already.
Yes.
Okay, good, good. What about the rest of you? Don't be shy.
Yes. I good.
Okay, so finish the registration.
Sí se pudo abrir.
Maybe I think I need to send this link again. Maybe some of you just joined the meeting and cannot see the message, so I send that again. Okay, once you finish the registration, you can see the second page. Because I'm the Huawei employee, I can use my Huawei account to log in. All right, and you can see there is a My Study, right? My Study, HCIA security training. You can click this. Click this. And once you choose the Olivia HCIA security training, and there is a blue button, which is enrollment. I believe everyone can see that, right? There's a blue button, enrollment. Oh, just me. It seems like, oh, someone have already joined this study group. Okay, in order to saving time, I'll show you the next step. Once you click the blue button here, which is enrollment, then you can start to learn. Then you can view the materials. All right. Now I click this keep learning. And you can see a new page. New page. And the second option is course contents. And here are the all the training materials of this course. 0, 1, 2, 3, 4 to 11. All right. And today's topic is network basics. So I click this one, network basics. And after several seconds waiting, you can see the training material, right? Just same with what I show you. Totally same, all right? Totally same. And this is the way to view the training material. And one more thing. After you finish the registration, which is step 1, right? And you can see your name here at the upper right corner. And please change your nickname as your real name. All right? Because after this class, the last day, we will have a small exam. So I need to know your score. And user center, right? You can see the user center, how to change the nickname. User center, click that. Okay, see that? Name and nickname. And maybe you can nickname, maybe you don't change, it's okay. But the name, I suggest you to change that, all right? Okay, after you change the name, then save. Click the save button, then you finish, okay? Let me check. Oh, classmates, just one. I'm waiting for you to join the study group. Okay, maybe you can try to finish this step after the course, after today's course. And we can move to the next part, all right? Move to the next part. Network basics. Have you ever
So
learned? Yeah.
sorry, I
Yeah.
can't find the course in the land page.
Let me see. You mean this one?
Yeah, I'm in home, but I can see this one.
You cannot see this one.
Yeah.
Can you open the link that I sent you?
Yeah.
Check the chat box. Can you open that link?
Yes, I can.
Yeah, and use your email box, email address to sign in, all right? Like this, email. Use your email address, email account, and get verification code. And after you receive that, input the code and click this one. I have read and accept and log in. And after you log in, you can see the page like I do.
Yes, I already done that. I can see latest courses, but I can't see my study.
You cannot see my study. What about the rest of you? Everyone cannot see, or just one people? What about the rest of you?
I could register normally. I just open again the link after register my email.
Uh-huh. And
And
can you see this one? My study.
yes, after registering,
Okay.
you need to enroll on the course first.
The first one, HCIA security training, right? You can see that.
Yes, we can.
Okay. Then we get started.
Okay. I could.
Now you can, right?
Done.
Okay, good.
Yeah.
Have you ever learned the network basics before? Because as I know, you're university students, right? Have you ever learned the network basics? For example, the switch, router, firewall, and routing table. How to send a message from one PC to another PC. What is the procedure? Have you ever learned that before?
Yes.
Okay. If you learn the basic knowledge of network, please send me 1. If you don't, send me 2. Let me check. 1. One, 3. Okay. What about others? Just 3 of you send me the message. 1. Okay, 4. Good. Okay, I see. Maybe we can start from the basic part because just 4 of you know the basic knowledge of network. Okay. Don't worry about that. Don't worry about it because today's topic is the network basics. I will introduce you. Okay, the first part is the network reference model. Network reference model. I believe that you have learned one thing is called OSI reference model, which have 7 layers. Layer 1 is the physical layer, and layer 2, data link, 3, network layer, and layer 4, transport and session layer, and presentation layer, and application layer. But what is the meaning of this OSI reference model? What is the function of this one? And you can see this model is raised by an organization, which is ISO, International Organization for Standardization. And this organization raised this model in 1984, far away from now, right? Okay. I'm going to show you the function, the meaning of this model. Very important. I'll use my pad. Okay. Now you can see the whiteboard, right? This is my whiteboard.
Yes.
Okay, good. Then let me show you the OSI module. And first layer is physical. It describes which kind of media we use between a PC or a router or some other network device. For example, this is your PC, right? This is your laptop or personal computer, and you want to view the internet. You want to view the internet or send a message to your friends, right? And you need to have Wi-Fi. You need to have Wi-Fi or cables, right? Wi-Fi or cables, a line or air. And the physical layer defined which kind of network media you use, Wi-Fi or cables or some other. And mainstream of nowadays is Wi-Fi and cables or fiber. And this is the function of physical layer, right? And it's just like if you want to send a letter to your friends, Alice and Bob, and Alice just wrote a letter. And she wants to send this letter to the Bob, right? Okay. Once you finish your letter, you need to put this letter into an envelope, right? Envelope. And on this envelope, you need to write down your address and your friends, which means Bob's address, your location, and the receiver's location, right? Okay. And name, right? Address and name. And name is Alice. Address, for example, China, Hangzhou province, Zhejiang, and city, Hangzhou, maybe block, blah, 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 right? Oh, sorry, something wrong happened. I need to restart this application. Sorry, this is broken. This is broken. Maybe Painter use the. Oh, this one is better. Okay. A letter, and you need to put into an envelope. Envelope. You need to write down some information on this envelope. Location, your location, and Bob's location, right? And name. And after that, you need to put this letter to the post office. Bring this letter to the post office. And the postman, the shipper will help you to send your letter to the Bob. Here is Alice, and here is Bob, right? And this procedure is the physical layer. The shipper drive his car, and send the letter to the Bob. And the car is a physical concept, right? Is a physical concept, and you need to drive this car to a highway speed, and that highway speed is one kind of physical layer, right? And maybe you think driving a car is too slow. You can choose the train, right? The train, high-speed train, or aircraft. Train or aircraft. And obviously aircraft is faster. It's faster, right? Okay. Can you understand the physical, the layer one, physical layer now? Layer one, physical. As the name suggests, it's about the physical stuff. You can send your letter by a car, highway speed, or train, or aircraft. That's physical layer. During that procedure, you send a letter from Alice to Bob. And the physical layer is to decide which way to use. Okay. And what about layer two? What about layer two? Data link encapsulates packets into frames, transmits frame in point-to-point or point-to-multipoint mode, and implements error detection. Actually, if I use a metaphor, just this example, send a letter from Alice to Bob. And first step, we have already know. Now we're going to use a car. The shipper will use the car, drive his car to Bob, right? And what about layer two? The shipper take your envelope, already have your letter, and it need to read the envelope. It need to read the envelope. He need to know, the shipper needs to know the location, right? The location. For example, now Alice is in China, Beijing, or Hangzhou, or Shanghai. Block, blah, 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 street, room number, right? So detailed information, very, very detailed information, room number. And that is layer 2 information. It's just like the layer 2 information. The shipper needs to know that information. And also your location, this location consists of 2 parts. And the first part is the Alice location. And second part should be the Bob location. China. Hangzhou, another city, right? Another city. Street. And room number. Maybe building. Right? Okay, this is layer 2. The physical address. The physical address. The shipper needs to know that. Otherwise, the shipper don't know how to drop this letter, right? He just know, okay, the receiver is Bob, but where is Bob, right? Where is Bob? We need layer 2 information. Layer 2 information. Data link layer, all right? Because inside of layer 2, there are one thing, it's called MAC address. MAC address. I'll show you later what is MAC address. And of course, VLAN. And what about layer 3? What about layer 3? Network layer, right? Network layer, which means IP address. And in this scenario, Alice sent a letter to Bob. Shipper used the car, drive the car to the highway speed, to the location, China, Hangzhou, maybe street 1, room number 403, all right? And the Bob can receive the letter. But one more thing, the shipper also needs to know is the name. The sender's name and receiver's name, right? And the sender's name, of course, is Alice. And receiver's name, Bob. And that's IP address. Is a logic concept. Logic concept. Why I said it is a logic concept? Because this time, Alice sent a letter to Bob. Maybe next time, Alice sent a letter to maybe Kathleen, right? Or Mike, or Jack. So name is just a name. For me, I am Gavin, right? But if I want to change my name, today my name is Gavin. And maybe tomorrow my name is Smith, or Harry, or Mike, right? It can be changed. Name can be changed. If you're not satisfied with your name, you can change that. So name is a logic concept. So the IP address too. One PC. Maybe your PC IP address today is 192.168.1.1. And maybe tomorrow you change that IP address. And tomorrow you can change that to 192.168.1.2. It's okay, right? Of course it's okay. So I said IP address is just like name. And name is a logic concept. You can change that. But the shipper still need to know that information, the sender's name and receiver's name. All right? Okay, and this is layer 3. And this is layer 3. Actually, this scenario, this metaphor can explain the concept from layer 1 to layer 3, but layer 4, layer 5 and 6 and 7, we cannot use that metaphor. All right, we cannot use that metaphor. So we back to the training slide. For now on, any questions? Am I clear about this concept The three concepts: physical layer, data link layer, and network layer. Am I clear?
Yes.
Good. What about the rest of you?
For me, it's clear too.
Yes, it's clear.
Okay, good, good. Then we continue. And let's see, layer 4, 5, 6, and 7. Transport layer. Now we need to back to the computer world. We need to back to the digital world. That metaphor is about how does a shipper send a letter from one people to another people, right? But now we need to back to the digital world because the layer 4, 5, 6, 7 cannot use that metaphor to explain. Okay, now the scenario is 2 PC. Delete. Okay. PC. Maybe this is not a PC, it's a server. This is a server. And this is your laptop, your PC. And now you want to view Google, right? Google. Google. Okay. How to view Google? Between your PC and the Google server is the internet. Or carrier network, right? Carrier network. For example, we assume that Google's IP address, the server's IP address is 8.8.8.8. Of course, this is the IPv4 IP address. 8.8.8.8. And your PC IP address is 192.168.1.1. And actually, this is a private IP address. Private IP address. And this is a public IP address. Okay, now we don't discuss about the private and public. You just need to know this is your IP address. And you need, actually, is your PC needs to send a message to Google. Ask for the Google server. Please show me your web page, the Google page. I need that. This is what your PC said to the Google server. All right. But maybe on this server, there are so many applications. One of the application is web. And one of the application is FTP. Okay, we assume that. The web, easy to understand, is the web page, right? Web page. Google. Search. Right? Search. And FTP is used to transfer the files, the documentations, right? For example, you need to download a video game from a website. Maybe you need to use the FTP protocol. And this server opened 2 applications. There are 2 applications available. One of the application is web, and another one is FTP, or maybe third one is DNS, or something else. Okay. Now, the PC knows the IP address of this Google server is 8.8.8.8. This is information he knew. But which application it need to be accessed? Which application? 3 options, 1 and 2 and 3, right? So the PC send a message to the server and need to tell the server which application he wants to visit, right? Okay. Layer 4. Layer 4. Layer 4 have one thing, it's called source port and the destination port. And destination port. PC need to tell the server, I want to view your web application, not FTP, not DNS. So the PC needs to put some information into layer 4 destination port, which is 80, and TCP 80. TCP 80. All right. And this TCP 80 corresponding to the web, which means HTTP. Okay. What if the PC now not want to open the website? He don't want to open the website page. He want to download some file from this 8.8.8.8. What about layer 4 information? What about the destination port? 21. TCP 21, right? And what about DNS? 53 UDP. So now you can know what is the function of layer 4, the port number. What is the function of layer 4? The port number. The key is the port number, right? And the port number is used to distinguish different application, right? And once the the server received the message, which is sent from the PC, and layer 4 information, destination port is 80. Okay, send to the server. Now the server know, oh, this PC want to view one of my application, and that application is HTTP. So I will show that guy my page, my website page. All right? Am I clear? Am I clear? Layer 4.
Yes, it's clear.
Okay, good. Since you know the meaning of layer 4, then we back to the training slide. If you have any question, please let me know, all right? Please let me, because this is the basic part. Very important. If you don't understand the module, the OSI, and the TCP/IP module, you cannot understand the rest part. Okay. Since no one asked me, I'll continue. Layer 1, 2, 3, 4. I have already explained the meaning. And the session layer, presentation layer, and application layer. Actually, the key part should be the layer 7, application layer. And that scenario, I just draw you this picture, this image, right? Image. PC try to access a server, and the server, one server have several applications. Open a website page, download a file, or make a phone call, SIP, or something else. So many applications. And each application have different function, right? And HTTP can show the PC, the page, and FTP can send the documentation and files to the PC, download or upload. And DNS can help the PC to get the IP information of a domain name. And SIP is used to make a phone call, right? Different function, and that is application. For example, WhatsApp and TikTok, all these stuff, or YouTube. I believe that every one of you may watch the video on YouTube or TikTok. YouTube and TikTok is one of the application. Right? And that's the meaning of application. But what about the presentation layer and session layer? Okay. What is session? What is session? And session is some kind of record. Some kind of record. Now, the Beijing time is 2025, November 17, 2046. This is the time, right? And this is time. And now my PC try to view the Google, right? And the Google needs to know the information, the time, and which PC try to visit me. It need to record those information. And those information will put into one table, and it is called session table. Or session list in the buffer, service buffer, or RAM, right? RAM. Why the Google server? Why the server need the session? Need this thing? Because we know inside of a session, so many informations, time, and the layer 3, the IP information, and layer 4 information, source port and destination port, and IP address, destination IP address and source IP address. Okay, why we need the session? It is because at the same time, not just one PC try to view the Google server. Maybe hundreds, thousands of PC at the same time open the Google web page, right? How to distinguish? For the Google server, how to distinguish, right? I have so many visitors, right? So many users, hundreds of users, thousands of users. How to distinguish them? Okay, session, right? One session corresponding to one user. Am I clear? Hello?
Yes, Kevin, it's clear.
Okay,
Yes,
good.
it's clear.
Good. And the presentation layer. It's just the middle part between the application and the session layer. Actually, nowadays, we don't need to think about these three. We don't need to think about this three. We just need to know the concept, all right? Because nowadays, we're using the TCP/IP reference model. The previous 30 minutes, I introduced you the OSI, which have 7 layers, so many concepts. It is complicated. It is complicated, and it is an ancient model, old model. But the latest one is the TCP/IP. It just simplified the OSI, right? At the middle part of this page is the OSI reference model. The left part is TCP/IP standard model. You can find differences between these two models, right? Nowadays, the mainstream is the TCP/IP. We do not use the OSI anymore. Why? Because the 7 layers too complicated. The differences between the TCP/IP standard model and OSI reference model is the layer 4, 5, 3 integrates together as one layer is application layer. All right, and the layer 1, layer 2 become one layer is the network interface layer. So for the TCP/IP standard model, we only have 4 layers: network interface and IP. The network layer, which in the TCP/IP standard model is called internet layer, which means the IP, and host-to-host layer, layer 4. Okay, but actually, this TCP/IP standard model is too simple. Too simple. At least in practice, we need to distinguish the layer 1 and layer 2, right? Because layer 1 is used to describe which kind of media we use. Wi-Fi, air, cable, fiber. But the data link MAC address is the physical location, physical address. So these two concepts is different. If we put these two concepts together, it's hard to describe the procedure of one PC or one device, one terminal, try to access another one. It would be confused, right? So the best practice should be this one. TCP/IP equivalent model. 5-layer. Physical layer equals to OSI module. Physical layer. Layer 1, same. And data link layer, same. Network layer, same. Transport layer, same. But application layer, it just put layer 4, layer 5, and layer 7, layers 5, 6, and 7 together as one application layer. So nowadays, when we talk about the TCP/IP reference module, it is this one, TCP/IP equivalent module. Please remember that. Please remember that. All right. Maybe some of you will ask you a question: how many layers does TCP/IP module have? Actually, you have two answers. And the first answer is if you want to ask me the standard module of TCP/IP, then the layer number is 4. And what about if you ask me about the TCP/IP equivalent module, then the layers is 5. Okay, but nowadays the mainstream is this one, equivalent model. It's clear and easy to use. Simplified, the sum part of the OSI reference module. Okay. And let's look at this page, the common protocols, which is widely used in our live network for each layer. A physical layer, it is the definition of the media. It's a media, air, cable, or fiber. And data link layer, which is layer 2, we have 3 mainstream protocol: PPPoE, Ethernet, and PPP. Actually, nowadays, most widely used should be Ethernet. And the second one is PPP. All right, it's PPP. And maybe you know another thing is called HDLC. Oh, this is the Asian one. This is Asian. We do not use that anymore. So we just need to remember the data link layer. Layer 2 is Ethernet and PPP. And the MAC address and VLAN information inside of the Ethernet. All right. This is the mainstream. Red. Highlight. Ethernet. And what about the PPP or PPPoE? This OE means over Ethernet. What is the difference between the Ethernet and PPP? Is the PPP have one function. It's called authentication. Authentication. Okay, let me explain that. Why we still need PPP? The PPP have one thing. It's called authentication. Okay, now you are at your home, and this is your laptop. Before you view the internet, you need to pay money to your ISP, right? Internet service provider, ISP. If we don't have ISP, everyone cannot view the internet. Okay, you pay the money to ISP, and ISP give you an account name and password. Maybe that account is bind to your cell phone number. corresponding to a cell phone number. All right. Okay. Account and password. Before you view the Google or TikTok or something else, you need to finish the authentication, right? You need to tell your account name and PWD to the ISP to prove that you are a legal user, right? This is a device or BRAS. You can understand this BRAS as a database. There are so many. You can think of this BRAS as a database. There are so many information of users. Maybe Alice, Bob, Catherine, Mike, Michael, blah, 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 and their account name and password, PWD. And the PPP is between your laptop to the BRAS. Before you view the Google, the laptop needs to send the information to the BRAS, and the BRAS try to compare the information received from the user to its database. If the account matched, for example, this is Alice. This is Alice, and she sent its account name and password to the BRAS, and it just matched the first entry. Okay, pass. The result is pass. Then authentication successful. Then laptop of Alice can view the internet, can open the Google website. All right, and that's PPP. It have the function of authentication. But the mainstream is Ethernet. Now the mainstream is Ethernet. So we need PPPoE, PPP over Ethernet, which means Ethernet and PPP together as PPPoE. PPPoE. This is the mainstream now. For the access network, how does a user finish the authentication and finally view the internet? This is the first step, PPPoE. All right. Okay. And then network layer. How many protocol in the network layer? The most important one should be IP. Maybe 30 or 40 years ago, we have ATM. But mainstream nowadays is just IP. I believe that every one of you know what IP is, right? For example, 1.1.1.1, or 192.168.1.1, or 172.16.1.1. And that's IP addresses, right? We have source IP address and destination IP address. And I still remember I mentioned the concept of IP before. I said IP is just like a name. And the name can be changed. So IP is a logic concept. Today you can use the IP address of this one, and tomorrow you use this one. It's okay. But we still need that. It's just like the people need a name used to distinguish from other, and that's IP. And ICMP and IGMP. What is ICMP? Actually, it is for test our network. Okay. I mentioned so many concepts. Maybe some of you confused. What is that? What is that thing? I don't know. You just keep talking the concept. I don't know. I cannot see, so I cannot understand. Okay, now I'll show you. I'm going to use the eLab, a practice environment, to show you something. Oh, 6. Huh. I'm happy. Schedule. Oh, eLab is not finished yet, but I can show you on my laptop. So I need to find it first. Where's eLab? Here. Okay, this is a simulation environment made by Huawei. It is called ENSP. This is a software. All right, software. Let me show you something. For example, a PC. And this is a router. Your PC and the router. Maybe this is a BRAS. Okay. Connect the PC to the router. And open this router. Start this device. Turn on. And PC. Turn on. Okay. When we're waiting, the router and PC turn on, we need to modify some attribute. For example, PC, it need to have an IP address, right? It need to have an IP address. For example, the PC1 IP address is 10.1.1.1, and subnet mask is 255.255.255.0. So the mask length is 24, all right? And the gateway is 10.1.1.254. Okay, apply. Okay, now the router 1 is up. So we need to configure some command line. Do some configuration. Sysname R1. And interface of this router 1 is Ethernet 000 interface. And you can see that the interface name begin with Ethernet, which means the router 1 use a Ethernet type layer 2, right? Layer 2 is Ethernet by default because Ethernet nowadays is the mainstream. Okay, interface Ethernet 0. Okay, IP address. Oh, sorry. This is too old. I'll change another one. This one is better. Hey, wait 10 seconds or 20 seconds maybe. And maybe you have already find something. Some interface begin with GE and some interface is just Ethernet. Actually, the GE is gigabit Ethernet and Ethernet is just Ethernet. The speed is different. The bandwidth of these two interface type is different. Ethernet is 100 M and GE is 1 gigabit. So bandwidth of these two interfaces is different. 100 and 1000. Okay. IP address. 10.1.1.254. Okay, 24. What am I doing? Now I'm trying to give the interface an IP address, 10.1.1.254. This is a gateway IP address. Why we need to configure that? Because PC1 try to access the router. All right. After the configuration, okay, we do this pin 10.1.1.254. This means successful. The PC successfully attached the router to this router. It is available. All right. And we can check the information between the PC1 and router 2. Data capture. Now I'm going to explain what is this Wireshark capturing from standard input. Now I want to catch the information between the PC1 and router 2. It's just like the PC1 is Alice and router 2 is Bob. PC1 and router 2 communicate with each other. All right. I want to see the information between them. I want to see the contents of the letter, and I want to know what Alice tell the Bob. So I open up this software, and it is called Wireshark, just like a blue flag icon. Okay. Now I use the PC1, try to ping 10.1.1.254. And this IP address is belong to router 2. 10.1.1.254. And this is 10.1.1.1. Okay. Okay. Inside of the Wireshark, we can see several messages, right? Source IP address 10.1.1.1. Destination 10.1.1.254. What is the meaning of that? Which means PC1 send a letter to the router 2. And this source IP address is belong to PC1, which is 10.1.1.1. And destination IP is 10.1.1.254 is router 2. And what's the letter? What is the message? Okay, the message is ICMP, protocol ICMP. And the ICMP is based on layer 3, which is network layer. It is a network layer protocol. Internet control and management protocol, which is used to test whether the link is available or unavailable, right? After we finish the configuration of IP address, the internet, the interfaces, we need to test whether it is good or not. So we need to use some method, and that method is ICMP, Internet Control Management Protocol, which is this one, PIN. PC send a message to router. If the router 2 reply this message, okay, we do the configuration successfully. Am I clear? Am I clear?
Yes, it's clear.
Okay, good.
Yeah.
Maybe some of you used the Cisco devices before. Already used the Cisco devices before, but this is Huawei. All right, this is Huawei. But ICMP is the industry standard. Every vendor obey this rule. Nokia, Cisco, Juniper, Huawei, some other vendor, use the same ICMP. It is a standard, all right? Okay, and this is ICMP packet. This is the ICMP message. Okay, see that? This one, layer 1, layer 1, layer 2, layer 3, and this is ICMP, not layer 4, all right? ICMP, the Internet Control Message Protocol. Sorry, it's message, not management. Message protocol, all right? Layer 2, MAC address, source MAC address, and destination MAC address. See that? This is a source, and this is destination, DST. And layer 3, source IP address, destination IP address. Okay. We're back to the training slide. And what is IGMP? IGMP, it is used for the load balance. Sometimes we need to use load balance. We have so many messages. One line, one fiber is not enough. We need to deploy several fibers or cables. Load balance. For example, I want to send 1,000 file to the destination. 100 sent to the first line, and the second 100 documentation or file sent to the second line, sent through the second fiber or cable, and that is called this is called load balance, and IGMP is used to control that procedure. All right, we don't explain too much about IGMP. Let's focus on the basic part, and transport layer, TCP and UDP. Do you still remember maybe 30 minutes ago, I tried to explain you the layer 1 and layer 2 and layer 3 concept. I draw you an image. Alice sent a message to Bob, and Alice's computer tried to open the Bob server, which is the Google server, 8.8.8.8. And that server has so many applications, FTP, HTTP, SMP, DNS, DHCP, so many applications. How to distinguish which one is the message which is used to access the web? Okay, layer 4, right? Layer 4, port number. But layer 4 also have two protocols. The first one is TCP, and the second one is UDP. And we can check the tips. TCP, Transmission Control Protocol, provides reliable connection. Reliable connection. What is the meaning of reliable? Okay, there's a very important concept I need to tell you. But before that, I need to take a screenshot. All right, wait a minute. Okay, TCP. A PC, a server, HTTP, which means web. Also Google. All right, Google. When the PC try to open Google page, before the server send the page to the PC, use the HTTP protocol, it need to establish a TCP link first. TCP link, which is TCP connection. And it is called three-way handshake. three-way handshake. Okay, what is three-way handshake? I just told you the TCP is a reliable connection. It do have a mechanism. Okay, the first thing the PC send is a SYN packet. It's just like I send a message to the server. Hello, I am Alice. All right, I want to open your web application. I want to, please show me your web page. Please show me your Google page. This is the first packet mean, SYN. Okay, after the server received the first message, SYN packet, then the server reply. If the server received that, then the server will reply SYN plus an ACK. Acknowledge. Which means, okay, now I received your requirement. Now I know you want to open my page. I have received your message. I confirm. Then the PC received the second one, right? SYN plus ACK. Then send the third one, ACK, back to the server, which means, okay, we can get a start. This is called three-way handshake. Every message need to have a confirm. I send you something, then you confirm. I send you something, then you confirm. This is called reliable, all right? Because when I send you 1,000 packets, I send you 1,000 letter, but you have no response. I don't know whether you have received or not, right? And this is not reliable. But TCP have a mechanism. Every packet will have a confirmed message, ACK, right? And that's TCP. That is called reliable. And what about UDP? Unreliable. There is no SYN and ACK, which means if PC and the server use the UDP protocol to send the message, there is no three-way handshake. I just start to send, and the server received that reply. But the PC don't know the message is correct or not. Maybe the PC won't send the message to the server, and the server supposed to reply 100 packets, but only 90% of packets received by the PC. 10% lost, but PC don't know, right? And this is unreliable. But TCP don't. Every packet have a ACK, have a confirmation. Okay. It's already 1.5 hours. Do you need a break? Do you need a break? Have a rest. Hello?
Maybe, yeah.
Okay, let's have a rest. "15 minutes, all right? After 15 minutes, we go back and continue."
Okay, thank you, Kevin.
Okay.
Okay, thank you.
Okay, it's about time to resume the class. All right. Let's go back. Before the break, I introduced you the TCP and the UDP, which is transmission layer 4 protocol, 2, TCP and UDP. And UDP is a reliable connection. Why? It is because before PC and server try to send something, try to communicate with each other, PC try to open a website, they need to establish a three-way handshake, confirm both sides is okay. PC send a SYN packet first, which means, hello, I want to visit your web application. And after the server received that, reply a SYN plus ACK packet, which means, okay, I received your response. And I reply you, which means, okay, you can visit, you can continue. And I received your message. And the PC received the second packet, then reply ACK, which means, okay, we can get a start. And after the 3 packets sending, and a reliable connection established between the PC and the server. All right, and this is called reliable. And the UDP, no such kind of mechanism. I just send, you just receive, no confirm. All right. But the TCP and UDP do have their own advantages and disadvantages. And advantages for TCP is, of course, reliable, right? But the disadvantage of the TCP is it consumes more resource of the hardware, because we know PC and server, they are just a machine. They're just a machine. They have their own limitation, storage space, CPU and memory, right? And of course, because the TCP protocol need to establish a three-way handshake, the connection, it consumes more resource for the server. Of course, the PC, same. But UDP, no. So the advantage of UDP is faster, less consumption of resource. But the disadvantage of UDP is unreliable, no confirm mechanism. Okay. And application layer. Then there's application layer. Telnet, FTP, TFTP, SNMP, HTTP, which is web, right? SMTP for the mail sending and receiving. DNS, and it is used to, for example, your PC want to view the Google server, and all the PC know is just the domain name of the Google, 3w.google.com. All the PC knew is that it's just a name, a domain name, but IP address, PC don't know, right? So before the PC try to visit a website, it need to ask a DNS server. Please tell me what is the corresponding IP address of the Google server. Then the DNS server reply the PC, okay, since you asked me, now I answer your question. The Google server's IP address is 8.8.8.8. Then the PC get this message. Okay, now I know. I want to find the Google, and Google is 8.8.8.8. Then I can send a packet. The PC can send a packet, right? Okay. And DNS. And DNS basically is based on the UDP, some scenario TCP, all right? And DHCP is used to allocate IP addresses. In SNMP, Simple Network Management Protocol, it is used to control the devices in our live network, right? For example, in your university, I believe every university, every company do have its own network. You have router, switch, firewall, IPS, WAF, so many devices, and it need to be monitored, right? I need to know the status in real time. I need to know if one router or one switch is down, is broken. SNMP can tell the server, SMP server, okay, there is one guy is down. Please try to fix that. So our manager can control that, can fix this. And this is SNMP. And telnet is used to connect to a device. As we know, we have so many devices in our live network, switches, routers, but how to configure that? We need a protocol. We need a protocol to connect to those devices and control them, send the command lines to them, and that's telnet. But telnet is not safe. It's not safe enough because it's plain text, which means all the message the PC sent to the device is in plain text. If there is a man in the middle, which means there is a hacker, try to steal the message between these two devices, which means the hacker can read some sensitive information, right? In order to resolve the issue, now we have SSH. Okay, far away from today's topic, but I will introduce you later. Application, okay. And please remember, nowadays we're used 5-layer TCP reference module is equivalence module, 5 layers. And one more thing, I mentioned before, layer 4, we have source port and destination port. And another concept is called the session. Maybe some of you are confused about that. So in order to facilitate understanding, I still need to tell you what is source port and destination port and what is session. Okay? Same scenario. PC access a server. Try to open HTTP. Now we can change. Not HTTP. This time is FTP. All right? FTP. And it is based on TCP 21. I mentioned the destination port is used to distinguish the different application. They have the mapping relationship, and FTP mapping to TCP 21, and HTTP mapping to TCP 80, right? And DNS mapping to UDP 53. Okay? Distinguish. This is a keyword. And let's see the procedure. I'm going to use the ELAB, the ENSP to show you. Okay. For example, now I have a server, and that server is an FTP server. All right. I need to modify some attribute. The IP address of the server is still 10.1.1.254. Maybe this time it's not 254, it's just 2. All right, it's just the 2. And gateway, no need to configure because the PC and the server were in the same network segment. All right, so no need to configure a gateway. Safe. And server info. Okay, this server can be a DNS, a HTTP, or FTP. Now FTP. root path. Okay, for example, disk C. And I need to start the server first. And I click the start button. And also, I need to change the PC. I need to use the client. The client. Actually, the client is the essence of the client is just one PC. All right, client 10.1.1.1. Save. Okay, and open. Start the device and link between them. And also, in order to facilitate understanding, I need to use the Wireshark to catch the packets between the client and server. Capture. Oh, sorry. It do not support, so I need to use a switch. I use a switch between them. Waiting for the switch turn on, power on. This is so important, so I spend a lot of time trying to explain what is IP address and what is session and what is layer 4 and what is source port and destination port. So important. Okay, now the SW switch already on and client. Double click the client, but before that, I need to catch the packet. Interface GE001. By default, this is just layer 2 information, STP information. Ignore that. Client, client info. Okay, now the client 1, try to download something from this FTP server, from the FTP server. So I need to tell the client what is the IP address of that server. It should be 10.1.1.2. All right. Okay, port number 21, TCP 21, and log in. Okay, successful. Removed files. We can see that. This is the file below the disk C of this PC. Local disk, right? Log, my test, private, public. See those files. And of course, I can download. I want to download this log.txt. Oh, sorry. There's no D. There's no D disk. I need to create a new one. Test. Okay, and double click C, and I go into the test. Download log text txt. Let me check. Some bug. But it's okay. It's okay. I think the Wireshark have already catch the packet between the client and server. Let's find the TCP connection. Okay, here it is. See that? Three-way handshake. Three-way handshake. 10.1.1.1, and this is the PC, right? And 10.1.1.2, and this is the server. And of course, the number 20 packet is sent from the PC because the source is the PC's IP and the destination is server's IP. And you can see the protocol is the TCP. See the detailed information of this packet. Layer 2 information, MAC address. Layer 3, IP address, right? See that? And layer 4, transmission control protocol. And see that? Source port 2090 and 49. Destination port 21. I want to tell you, commonly saying, when we use the PC try to visit a application on the server, the destination port is determined, but the source port random. Maybe this time is 2049. And next time, maybe the PC will use 3049 or 4049 or 5000, 6000, 10,000. It's random, all right, totally random. But the destination port, it is because the PC try to access the server, and the server's application is a specific one, is FTP, and FTP corresponding, the mapping destination port is 21. So whenever, how many times you try, the PC try to download, connect to the server, the destination port will always be 21. But the source port, maybe next time change, all right? But this time, the PC used 2090 and 49. This is the first packet. And here's another concept is called 5 tuple. 5 tuple. Which 5? First is the source IP address and destination IP address. This is 2 tuples, right? And 3 and 4 is the source port and destination port, which means 2049 and 21 destination port, TCP. And what is the last tuple? TCP, right? And this 5 tuple can determine one link, can decide one link. And this 5 tuple is the key information of a session, which means a server at the same time, maybe hundreds and thousands of PC try to access that server. And each PC, between the PC and the server, need to have a session in order to distinguish different response and reply. Okay, and one session, 5 tuple, during this visiting, never change. Okay, I'll improve you that. I will prove you that. See that? And this is the second packet reply from the server, right? SYN and ACK. And you can see the layer 3 information. Source is 10.1.1.2. Destination changed to 10.1.1.1. It is because the second packet is reply from the server sent to the PC. In the opposite way, first is 10.1.1.1 to 10.1.1.2, and the second is 10.1.1.2 to 10.1.1.1. Easy to understand, right? Alice sent a message, wrote a letter sent to the Bob, and Bob replied the letter to the Alice. Okay, and let's see the layer 4 information. And this time, the second packet, the server used the source port as 21, destination port as 2049. Don't change. The 5 tuple don't change. 2 IP address, 2 port don't change, and TCP don't change. All right. And maybe you ask me one question. What is the scale of IP address and the port number? I can answer you. The port number range is from 1 to 655 65535. Sorry. Six. This is the port range. Both the source port and destination port range theoretically is 1 to 65535. But for the destination DST port, the first packets, the SYM packet destination port, can be used to distinguish which application that PC try to visit to. All right, and the source port is random from 1 to 65535. Okay, and that's PC send message to server. This is the direction. Direction is very important. It's PC send the first packet to the server. Pay attention to my word, first packet. All right, first packet, because the first packet determine 5 tuple. Okay, back to the Wireshark. See that? 5 tuple, don't change. And third one is a ACK packet, right? ACK. I said the third packet is just like the PC received the reply from the server, and the PC said, okay, we can get a start. And for now on, the TCP three-way handshake established, right? See that? Layer 3 information, 10.1.1.1 to 10.1.1.2. And source port still 2049. And this destination port still 21. Right? Okay. This is three-way handshake. And those 5 tuple can determine 1 session. And the server used these sessions to distinguish different users. Okay. And the rest part is the FTP. Since the TCP connection is established, they are trying to, the PC and server try to communicate, try to send the document, try to send files. So the rest part is the FTP stuff. FTP stuff, right? And you can see the source port, destination port don't change. 21, 2049. And next one, 2049, 49 and 21, right? Don't change. Am I clear about this part? Hello? Are you still there?
Yes, Kevin.
Okay, good. You are my true friend. Okay, and the rest part is the introduction of each layer. For example, application layer. Used to transfer the real data. The purpose of sending a letter from one people to another people is the sender try to tell something to the receiver, right? So the key information is inside of that letter, and the application is that letter. All right, including data. But there are so many types of application: FTP, HTTP, SNMP, SIP, so many. Okay. This is FTP. But one thing I need to tell you is I introduce you the FTP and show you the packet between the PC and server. But one thing I haven't tell you is an FTP is a multi-channel protocol. multi-channel protocol, which means the FTP have two stages, stage 1 and stage 2. Stage 1 is used to control this link, used to authentication. And stage 2, transfer the data, transfer the real data, all right? So the stage 1, the fixed port is 21, and stage 2, fixed port is 20. I will show you later. When we try to talk about the firewall, I'll show you what is the difference between the multi-channel protocol and the single-channel protocol, okay? SFTP, Secure File Transfer Protocol. FTP is the file transfer protocol. So SFTP and FTP difference is just one, this S, which means secure. Encryption, encrypted. Because FTP, when we send the information from the client to the server, those data without encryption, which means plain text, if there is a hacker between the client and the server, sorry. Okay, PC and server, if there's a hacker, the hacker can steal the information between the PC and the server. Maybe hacker plug in a switch between the PC and server. So the PC and server communicate with each other. All the information stolen by the hacker. And the hacker can read information, right? For example, PC send, download a server, a file from the server, which is a TXT. And the TXT have several entries. One of the entry is the bank card number and password. This kind of information is so sensitive, right? If the hacker can steal those information, terrible, right? Terrible. So in order to fix this, in order to resolve that problem, we need to upgrade FTP, which is SFTP. The plain text after the math function algorithm, it will transfer to a ciphertext. And even if there is a hacker between the client and server, and the hacker steal the message and try to read the data, the hacker will find this time he cannot understand what they're talking about anymore, because the plain text already becomes the ciphertext. Ciphertext cannot be read unless you have the key to decrypt it. All right? Okay, I will explain that later. With higher security compared with FTP, and that's the difference. Okay, telnet. And telnet is used to log in to our devices. The client, our network manager, try to send a command to our firewall server, switch, and router. By which kind of application? Telnet. All right. Okay. For example, we have a lab information. This is our practice environment for this course. And maybe from tomorrow, I will leave you some time to practice by yourself. For example, configured, try to modify the FW and the router and switch, right? And use the PC to log in to the firewall and write down some security policy. I will leave you some time to practice by yourself. All right. And this is a topology. But first of all, we need to log in to those devices and then we can modify. Okay. Let me show you. I need to take a screenshot. Okay, let me show you the telnet here. Have you ever used secure CRT before? It's one kind of terminal. It's one kind of terminal software. If you have already used secure CRT before, you have the experience, send me one. If you don't, send me two. Two, okay. Okay, I'll show you how to use that. What is the logic of the secure CRT? I need to show you some. Give you a new image. Now the scenario is like that. This is your laptop. We assume that now you are a network engineer, and to maintain the devices in the warehouse is your job, is your daily job. All right. Okay, so now you need to use your laptop, log in to those devices. For example, this is a switch, and this is a router, and this is a firewall. How? Okay. First, you need to download the secure CRT. CRT. And of course, the secure CRT is just one of the terminal software. We have Xshell. You can also use Xshell on mobile, Xterm, or Super PuTTY. They have the same function, all right, but developed by the different vendor. And the most typical one is a secure CRT. It's just a software. And inside of the secure CRT, we can use the telnet. Telnet. This is a protocol, and TCP, based on TCP 23, all right? TCP 23. And this 23 is the DST port, right? Destination port. Okay, now you try to control those devices, right? Then you install the secure CRT and do some configuration. Then you can connect to the switch, connect to the router, and connect to the firewall, and send the command. For example, reboot. This is a very dangerous one. Reboot. Or reset. Or wrote down a route information. Modified routing table. Then you can control those devices, right? Through the telnet. This is a protocol. So this kind of application is just like the language between machine and machine. Your laptop is a machine, and SW, router and firewall, machine. And machine need the different language to achieve different goals, right? And this scenario is your laptop, this machine, try to control another machine, use the telnet. and the telnet is the language. All right. Okay. How to use secure CRT? First of all, open that and then see that there is a plus icon, new session. See that new session. Click this plus icon and you can see connection, right? Okay, let's open the topology. For example, now I want to log in to this router. I want to control the router 1 now, RT1, which means router 1. All right, and we can check the login information of the router 1. This is router 1, right? Okay, IP address of this router 1 is 172.21.23.9, right? Okay, then we copy this information. Control plus C. And okay, back to the secure CRT. Now the language is telnet, right? We're going to use the telnet protocol to control the device. So the protocol, we need to shift to the telnet, not SSH. All right. Okay, telnet. Then you can see the secure CRT asks us to modify the IP address. The host name means IP address. Control plus V. This is the IP address of the router 1. All right. Okay. And we need to name this connection in order to distinguish, in order convenient for us to read router 1. All right. Okay. And press the OK button. And before we press the OK button, and we need to confirm again the information. Host name 172.21.23.9, correct. And port number 23, correct. By default, the telnet port number is 23. Okay. And we can find there is a new session. It is called router 1. And we double click it. See that? Login authentication. Of course, if you want to log into the device, you need to have the correct account name and password, which means username and password. And where is the username and password? See that? User and password. ADMIN, admin, which means administrator, the manager of the device, the manager account of the device. And the password is huawey at 123. And H, the first H is in uppercase, not lowercase as uppercase. Okay, let's log in, try to log in. ADMIN, admin, all right? Password, huawey at 123, enter. Then we log into the router 1 successfully. That's secure CRT and telnet. CRT is just an application. And telnet is a protocol. The relationship between the CRT and telnet is, the terminal is a protocol. It's just like a program installed inside of the secure CRT. We can telnet a device through the secure CRT. All right. Okay, since we log in, we can control the router 1. For example, we can rename this device. See that? This is Huawei command line. The name of this device is router 1. We can check its routing table. For example, display IP routing table. IP routing table, right? See? These are the information. So how can we control the device? Because telnet. Am I clear? Am I clear? I just showed you what is telnet. Client program, right? Used to control the devices.
Yes, it's clear.
Okay, good. Okay, good. And S-telnet is SSH. All right, SSH. SSH is a framework, consists of two parts. One part is S-telnet, and second part is SFTP. All right, which means S-telnet plus SFTP equals to SSH. Okay, and the port number of SSH is 22. 22. TCP 22. Okay, maybe you're confused why I try to tell you the port number. And with the port number, I always said TCP 22, TCP 80, TCP 21, UDP 20. Well, what is the meaning of that? Okay, explain. I said telnet is based on TCP 23, right? Which means the PC sent the first packet to the server. Of course, it's a TCP packet, right? And SYN. Destination port is 23. All right? Okay, what about UDP? If a application is based on UDP, then if I try to visit the server, that application is based on UDP. Okay, PC, server. For example, DNS. By default, DNS is based on UDP 53, which means the first packet that PC sent to the DNS server, the destination port is UDP 53. Okay, let's check the Wireshark again in order to help you understand. Where is the... Okay. This is layer 4, right? Layer 4. TCP, destination port. If now we use a UDP application, it will be UDP, destination port, blah, 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 and source port, blah, blah. All right? Which means basically, theoretically, how many possibility does our have to create the different application? How many kind? It should be UDP. UDP 1265535 and TCP 1265535, right? Plus, that's all the possibilities, right? Okay. Let's continue. And SSH is based on TCP 22. And if we want to configure the SSH as telnet, it's a little bit complicated than telnet, all right? But the function of the S-telnet is very similar with the telnet. The only one difference is the S-telnet is much more safe than the telnet, because the S means the packet between the client and the device has been encrypted before sending. All right. Okay, HTTP. Two method, post and get, right? Post and get, post and get. Hypertext transfer protocol. Actually, this is a very ancient protocol. I believe that every one of you tried to open a web page so many times one day, right? And when you try to open your browser, Chrome or Edge, actually you're using the HTTP protocol. For example, if we click this one, if we click the web page, you see that? To use a new one. Yeah, see that? It should be like that. The complete domain name, the URL, is begin with HTTP. And you can see this URL is HTTPS, not HTTP. The relationship between HTTPS and HTTP is just like the S-telnet and the telnet. The difference is this S, secure, which means the HTTP without encryption is dangerous. The message between the client and server is plain text. Everyone can understand what they are talking about. If you can use your technology to steal the message between them, you can read. But if it is HTTP plus S, okay, even if you steal the message between them, you cannot read. You cannot understand. Okay. This is HTTP. Visit huawei.com and the server reply and the HTTP client, which means your PC or your laptop, show you the Huawei page. Yeah, see that? HTTPS plus TLS. And of course, HTTP and HTTPS is also based on TCP, not UDP. HTTP is based on TCP 80, which means the destination port should be 80. And source port random. And what about HTTPS? See that? Based on TCP 443. Destination port number should be 443. All right. DNS 53. What is the function of DNS? I mentioned before. A client, for example, this client tried to visit huawei.com, this URL, right? This link. But the client don't know the IP address. If the client don't know the IP address, he can never visit a website. He can never visit a single server. No, because the IP address is necessary. Very, very necessary. If you don't know the IP address, you cannot. So in order to know the IP address, the client need to ask the DNS server, I want to visit the huawei.com. Please tell me the IP address. And the DNS server just reply, return IP address, x.x.x.x. And then third step, the client. Now the client know the specific IP address of the huawei.com. Okay, access. Try to establish the Huawei server with a TCP three-way handshake connection, right? Because if an application is based on TCP, whether it is FTP, HTTP, HTTPS, or S-telnet, the first step always establish a three-way handshake. What is three-way handshake? Do you still remember? I'll show you. See that? This is three-way handshake. SYN, SYN ACK, ACK, 1, 2, 3. This is just FTP. If the server is HTTP, same. 3 packets, SYN, ACK, and ACK. The difference is the destination port, all right? And of course, the source port, because each time the port number is different. In order to prove that I'm correct, okay, see that? In this connection, the first visit from the client to the server is 2049, right? What about I disconnect and try to connect again, which means a second visit. Log out. All right, log out. Log out. See that? Log out. And log again. Okay. Let's check. See? This is the second try. And this time, the source port is 2051, not 2049, right? It changed, and it is because the ENSP is a simulate environment. For the real device, totally random, all right, totally random. Maybe 3,000, 5,000, 8,000. It can be any port, all right? And the second try still need to establish the TCP three-way handshake because FTP is based on TCP. The reason why I repeat a TCP three-way handshake so many times is I need you to remember this, all right? Very important, because the firewall working mechanism is based on this, all right? Based on the session, based on 5 tuple. Okay. This is DNS. Check the. Oh, it doesn't mention the port number, but I tell you is by default is UDP 53. All right. Okay. Transport layer, I already introduced you so many times. End-to-end connection. So the keyword is the connection, three-way handshake connection. And the second key word is reliable. Every message have a confirm, one SYN, one ACK, one SYN, and one ACK. Every message have a reply. Okay. And this is the format of TCP and UDP packet formats, right? TCP packet header is like that. Okay. Source port, destination port, sequence number, acknowledge number, head length, reserve, control bits. Okay, let's see the real one. See that? Source port, destination port, sequence number, acknowledge, flags, window size value. This is the format. This is the format, and it is fixed. TCP format, and UDP is like that. Much more easier than a TCP. So that's why I said the advantage of TCP is reliable, but slower because it's so many information. It consumes a lot resources, right? Okay. Port number, right? Port number. let's make a metaphor. For example, if you want to talk with someone, for example, I'm a single man. I try to make a girlfriend, and I do have a girl. I like her, but I try. If I want that girl be my girlfriend, the first step I need to talk to her, right? I need to talk to her first. But before I talk to her, I need to know what is her hobby. For example, her hobby, maybe movie, maybe sport, maybe reading books, maybe listen to the music, not video game, right? So I need to find a correct hobby. If I talk to this girl, would you please play the video game with me together? Okay, maybe she just go away. Oh, this man is a psycho because she don't have the interest on video game, right? So the correct way is, could you please, can I watch a movie with you tonight? And maybe this time the girl, okay, I like to watch movie, and I can date with you, right? So those hobbies, just like the, how to say, the applications, FTP, HTTP, and DNS, you need to choose the correct one. And how to distinguish those hobbies, how to distinguish those applications by the port number. By the port number, all right? Because the machine is just the machine, is not human. It needs some attribute to distinguish the different application. It's the digital world, so port number. Okay. And this is the TCP and UDP port numbers. I think you have already know. And if you still don't know, if you're still confused about this concept, don't worry. The next day, maybe second day and third day, during this course, you have the time to practice by yourself, and you can use the Wireshark to catch the packet between devices and devices and check the port number. And finally, you understand what is port number. And of course, if you confused, you still have the question, ask me. All right. If you don't ask, I don't know. Okay, take a small break for 5 minutes, all right? 5 minutes. Okay, let's go back. Resume the class. 20 minutes left. All right. I know maybe you're tired. Maybe you're tired. Just 20 minutes. We already discussed about the TCP and UDP, which is layer 4, right? The port number. The key point is the port number. The source port is random and destination port is fixed based on which application you want to visit to, right? So that's why we keep talking about what the application 1 is based on TCP, blah, blah, blah. Application 2 is based on UDP, blah, blah, blah. That's the reason. It's about the port number. Okay, network layer, IP address. IP address. The key information of the network layer is source IP address and destination IP address, of course. And I also mentioned the IP address is just a logic concept because IP address can be changed. It can be changed days, years, month, right? Maybe I can change my IP address after 5 minutes. So it is a logic concept. And this is the format of the IP packet header. And let's see that. So many attributes: version, length, ES field, total length, identification flags. And this part is fixed 20 bytes, 20 bytes. But if we plus the information of IP options, it's variable. It's variable, all right? Maybe 40, maybe 60 length. And let's check. Go back to the Wireshark. I think Wireshark is a very good thing. It can help us to understand the format of the IP packet. See? Version 4. The 4 means IPv4. What about IPv6? The IPv6 is much more complicated than the IPv4. I mean, the length of the IPv6 is much more longer than the IPv4. And the length, right? The header length means the layer 3 information total length is 20 bytes, because there is no extension part. For this packet, there is no IP option information. So the length of this packet is 20 bytes. Source IP address and destination IP address. That's the key. Okay, then IP packet forwarding. IP packet forwarding, which means the layer 3 device is based on IP packet forwarding. See that? Router. Of course, router is a layer 3 device, and switch is a layer 2 device. The difference is the router can handle the information of the IP, but switch by default not. Switch can only read layer 2 information. It's not the responsible for the switch to read L3, all right, by default, I mean. And what is IP packet forwarding? Okay, let me show you. Okay, this is your PC. And ISP, network, which means internet. and you want to send a message to another PC. This is PC1 and this is PC2. Okay, Alice and Bob. So the question is, how does the Alice find the Bob? Right? How? Because in ISP network, maybe it have hundreds of routers. Router. So many routers and firewall or switches. For those router, yeah, Alice sent the message to the router 1. And maybe Bob is connected to router 100, all right? How does router 1 know where is Bob? Right? This is the problem. Actually, for each router, the only thing the router need to do is check one table. And that table is called IP routing table. IP routing table. Okay, for example, if the Alice PC of Alice IP address is 1.1.1.1 and PC2 is 2.2.2.2, which means Bob. Okay, Alice proactively send the packet to the Bob, and the packet should be like that. This is IP packet. Layer 1 information, physical information, ignore that. Layer 2, MAC address. Okay, the key information should be layer 3, IP address. An IP address, source IP, SRC, source IP, 1.1.1.1. Destination, DST. IP is 2.2.2.2. And layer 4 and layer 5. Actually, the router don't even care about the layer 4 and the layer 5 information, because the layer 4 and layer 5 is should be handled by the Bob's PC, PC2. The router is just a layer 3 device, which means when the router received the packet sent from Alice, the router 1 just read this part, the IP address part. And that's how router work. And router received L3. First, check the destination. Check the destination. Okay, this guy want to go to 2222. Okay, now I need to check my table to see where is 2222. So the router 1 will check its routing table to find out where is 2222. Let me show you what does a IP routing table looks like. Here, router. Okay, this time the client is 1.1.1.1 and the server is 2.2.2.2. Alice and Bob are okay, and between them, so many routers. But in order to simplify the topology, I just drag 2 routers. All right, router 1 and router 2. Wait for about 1 minute. This part is internet. Or ISP. Okay, and we need to design IP address. This is 1111, right? Okay, this is 1.1.1.2. And IP address between router 1 and router 2 should be 12.1.1.1. And for the router 2, this interface is 12.1.1.2. And for the router 2, G000 2.2.2.1. All right. Okay. And server. Gateway. This time we need gateway. Okay, and this time, for the client, also need a gateway, 1.1.1.2. Actually, this is the datacom part. In order to understand the HCIA security, we need to have the basic knowledge of the datacom. Okay, router one. The name of this router is router 1. Okay, let's check the routing table, display IP routing table. And this is the command. Okay, by default, if we don't do any configuration, the IP routing table of router 1 only have 4 entries. And these 4 entries default configuration. All right, but the question is, the client 1 try to access the server 1, 1111 to 2222. If we don't configure the information, let's see what will happen. Okay, maybe I'll change a client, not your PC. This will be better. Now I try to use the PC, try to test whether the server is available or not. Pin 2.2.2.2. See that? Destination host unreachable. See that? Destination host unreachable. Why? Okay, of course, I don't configure the IP address of the router 1 interface 000 yet. So I configure that. Interface G000. IP address 1.1.1.2. And mask length is 24. Okay. Is that enough? No. Request timeout. This time, request a timeout. Still unavailable, right? And we can use the Wireshark to check the information. I catch the interface G000. and also catch the interface G001. Okay, there are two Wireshark windows. First is between PC1 and the router 1. And the second window is between router 1 and router 2. All right? Okay, then we use the PC, send ICMP packet to test the 2222. You request a timeout, right? Okay, let's check the Wireshark. Wireshark, first window is between the PC and router 1. We can check the ICMP packet, 5 ICMP packet, all from PC1. 1111 try to access 2222, right? Okay. If the router 1 know where is 2222, then the router 1 should send the packet to the router 2, right? Because these 5 packets just like 5 letters, from Alice to Bob. 1111 is Alice, 2222 is Bob, which means the router 1 needs to deliver the packet to the router 2, right? But what is the result? Second window, nothing. It's empty, right? Which means router 1 don't send the letter to the router 2. Why? Because, let's check. Display IP routing table on router 1. The message sent from the PC destination is 2222, right? Okay, when router 1 receives the packet, it needs to check its own map. That map is just the routing table. And we can check the destination. 1111, of course, the router 1 know where is 1.1.1.0 or 1.1.1.2 because it's the direct link. That's the link that router 1 direct connect to the PC. So of course the router 1 knows that. But what about 2222? The router 1 don't know because there is no route information, right? It's just like I have a car and I want to travel from Hangzhou, China to Bolivia, your country, right? So I need a map, a digital map, for example, Google Map. If I don't know, if I don't have the map, I have no idea where your city is, right? I don't know how to drive. That is the reason. It's just like the router 1 miss the map from 111 to 2222, which means the router 1 don't know where is 2222. So that's why the second window is empty. And this is layer 3 information. All right. Okay. So how to make this topology, how to make sure that PC1 can access the server 1? We need to tell router 1 where is 2222 and also tell router 2 where is 2222. And the reply packet 2222 send back to the PC1 1111. The router 2 also need to know where is 1111, right? Okay, let's configure. Router 1 interface router 1 between router 1 and router 2. 001 IP address 12.10 and router 2. Okay, test ping 12.1.1.1. Okay, it is available. And then interface G000 on router 2. It is direct connect to server 1, right? Server 1. But before that, we can check the routing table of router 2. Router 2's map, right? And the router 2's map have this 3 entry. It is used to describe where is 12.1.1.1, right? Because I configured the interface 001, so router 2 knows that. But the router 2 don't know where is 2222 because I haven't created the IP address on 000, interface G000. Then we do that. IP. Yeah, now the 000 have the IP address. And then check the routing table, check the map again. See that now the router 2 do know where is 2222, right? Shows on the map. Okay. And now let's try PC1, access the server 1. Is that available? No, still no, right? Why? Let's check the router 1. Display IP routing table on router 1. There is no entry describe where is 2222, right? So we need to roll down a entry to tell the router 1 where is 2222, right? Okay, how to? It is called static route. Is our human tell the machine how to go to a specific destination? IP route static 2.2.2.2, 32. Next hop is 12.1.1.2. Okay, what is the meaning of this command line? It's our human tell the router, if you want to go 2222, send this message to the 12.1.1.2 first. Okay, let's check the routing table. After I configure the static route, now we can see on the router 1, there is a route entry. Describe where is 2222, right? See that? Next hop. What is the meaning of next hop? Okay, after I explain this point, we finished today, all right? Next hop means if you want to go to the final destination, you need to go to the next station. And where is the next station? This is the meaning of next hop. And for the 2222, next hop is 12.1.1.2. And where is 12.1.1.2? Here, router 2, right? Hop by hop. Station by station, segment by segment. That's the meaning. Okay. Now we try to use the PC1, ping the 2222 again. Yes, the result is timeout, but we can check the second window of Wireshark. See that? Now the router 1 send the information 1111 to 2222 because this time the router 1 already know where is 2222. So the router 1 will send the message to router 2. But why still timeout? It is because the router 2 don't know where is 1111, right? So we can tell the router 2 IP route static 1.1.1.1. Since we have come, it must have go, right? Come and go. Now the router 2 have the root information of where is 1111, right? Before that, the router 2 don't know. And then try again. See that? Successful. And that's layer 3 forwarding. Every router need to have the destination. Where is destination? That information. That is called root entry. That is called roots. That's L3 forwarding. I think now you understand what is the key point of L3 forwarding. It's all about root information. Am I clear about this part? Am I clear?
Yes, Kevin.
Okay, good. Very good. Because it's about time, right? It's about time. It's already 11 o'clock. So how about we just finish today and we continue this part tomorrow? The basic part, very important. If I don't explain the basic part, you will not understand the rest of the part. All right. So tomorrow we end the class, and today we end the class, and tomorrow we continue. All right.
All right,
Okay.
Kevin.
Yeah. See you tomorrow.
See you tomorrow, Kevin.
Yeah. Good.
See you tomorrow.
Thank you. See you tomorrow.
Yeah. Thank you.
Thank you. See you.
See you. Bye.